So who remembers what we were talking about yesterday during math? You guys forgot during math. During math. Miss Alonso was teaching the math.
Oh,
Yes.
we were adding and subtracting fractions.
Okay, now let me ask you this. On those fractions that you were adding or subtracting, did they had something in common?
The denominator.
Yes, the denominator was common. Okay, just like we have up here on the board. Now I am going to select two volunteers
No.
to come and solve them. Do you know how to catch?
Only pick the ones
Are
that
you
don't.
good at catching? Like really, really good?
Can you only pick the ones that are
Number one.
not?
Okay, let's pay attention to foil. I was gonna say this one.
It stays the same because it's the same denominator, and this is 4, and it's already in its simplest form.
Very good. I like how you made a connection to, how you have to simplify it. Like even after you solve for it, you have to simplify it. Very good, Joel. Very good, very good. Next volunteer.
Catch.
You're supposed to catch.
So what we're gonna do is, and then how it was the same, they're the same almost.
Good.
And then, so.
Very good. Very good. Good job.
Can you do more?
Now I do want to mention that I really like how you respect your classmate, by not talking, by not telling him, oh, this is very ugly, or the numbers, or I can see, or whatever. So I just want to tell you that I am very happy to see that. So yes, now that is also in its simplest form, so we cannot even, go lower. We cannot even simplify because it's already simplified.
Can you do 6?
Huh?
Can you do? Okay.
Can I what?
A question because I just wanted to get the marker.
You just wanted to get the marker?
Yes.
Okay, fine, we'll do another one.
No, I was kidding.
Okay.
No, he wasn't.
Anyway,
I was kidding. I
so
was
in
kidding.
today's lesson, please help me read today's objective. 1, 2, 3.
Be able to add fractions with unlike denominators successfully 4 out of 5 times.
I am actually surprised that you realize that this is a 4 and not a 9. Like everybody tells me that. Why do you have a 9? That looks like a 9.
That does not look like a 9.
If it's a 9, it should be a 9.
Yeah, so anyway, today we're going to be doing the same thing, but we're going to be working with different denominators. Okay? So, let me show you an example. Right here. Okay, so we have, you can see a TV too, right?
Yes.
Okay.
Think the camera was
So let me erase this. So now, does anybody have an idea on how to solve for this?
Yeah, me.
You do? Can you tell us how?
First, the denominators are not the same, but you could change the 5 into a 10 by multiplying the 5 times 2, and whatever you do to the bottom, you do to the top.
Very good. Have you seen this before?
Many times.
Many times? Okay, good. I'm still having trouble with this. So, one of the best ways to learn is to teach. So let's see if also by the end of today's lesson, I am able to do this, okay? So you were saying that I'm supposed to multiply this. How did you know that it's a 2? Like, do we always do it by 2 or?
No, it's because 5 times 2 equals 10, and the denominators need to be the same.
the denominators need to be the same. Okay. So I multiply this times 2
And you do the same with the 4.
with the 4.
Mhm.
Do I multiply the 1 times 2?
No.
Why not? Because this is not even part of this fraction, right? So this has nothing to do. Okay. Good. And what is 4 times 2? I keep forgetting my times tables.
Oh my god.
Yes.
8.
8. What about 5 times 2?
10.
10. No, is that my answer? No, then I have to rewrite the whole problem now with our new fraction, right? Okay, so just imagine it's a name.
You can erase it and do it again.
Okay, here you go now. You can solve this. Yeah, I already converted into a.
Catch it.
I don't know
Catch
that
it.
number.
Okay, Axel, careful with the camera.
At least I have it right.
Good.
Quick math.
Thank you, sir. So now I'm going to have my friend Mr. J explain this a little bit better. Because I heard you like those videos, right?
Quick math.
There's a lot of J's in here. There's no J's.
Like the YouTuber.
What's up, Jake Paul?
What's you?
What's up, Jake Paul?
So let's go ahead and pay attention to this video, please.
Add fractions with fractions.
Welcome to Math with Mr. J. In this video, I'm going to cover how to add fractions with unlike denominators. So let's jump into our examples, starting with number 1, where we have 4/9 plus 1/3. Now when we add fractions, we need a common denominator. In other words, the bottom numbers need to be the same in order to add. For number 1, we have a 9 and a 3, so obviously we don't have a common denominator to start with. So we can't add quite yet. So the first thing that we need to do is find a common denominator. And we can do that by finding the least common multiple between our denominators. Now, as far as why we need a common denominator, that's a topic for another video. I'll drop that link down in the description. So you may recognize the least common multiple between denominators right away when you see the problem, but if not, you can always write out your lists of multiples in order to find it. Let's write out the multiples of 9 and 3. So I'll come to the bottom of the screen where I have some extra room to write out these lists. We'll start with 9. So 9. The first multiples of 9 are 9, 18, 27, 36. So I'll write 4 multiples of 9 there. I would suggest writing out 4 or 5 multiples of each. See if you have any common multiples, and if not, you can always extend your lists. So let's do 3 now and see if we have any common multiples. 3, 6, 9, and it looks like we have a common multiple of 9. And more specifically, that's going to be the least common multiple. We always want to find the least common multiple. Smaller numbers in value are generally easier to work with, and this will help cut down on simplifying in the end. So 9 is going to be our common denominator. Let's come back up to the original problem and rename these fractions with our common denominator of 9. So underneath, I'm going to write our common denominator of 9, and now we can rename. So we'll start with 4/9. Well, 4/9 already has a denominator of 9, so we don't need to rename. So we can just bring the 4 down. As far as 1/3, we need to think 3 times what equals 9? How do we get 3 to equal 9? Well, we know 3 times 3 equals 9. Now, in order to rename, we want to have an equivalent fraction. We want to keep this equivalent. We do not want to change the value of the problem at all. So whatever we do to the denominator, we have to do to the numerator. So 1 times 3 is 3. 3 nines is equivalent to 1/3, but we have that common denominator of 9 now. Now that both fractions have a common denominator, we can add. So when we add fractions, we add the numerators, the top numbers. 4 plus 3 is 7. And then we keep the denominator the same, so 9. 7 ninths is our final answer. Now it's common practice to simplify fractional answers. So we look to see if we can break this fraction down at all. Are there any common factors between 7 and 9 besides 1? Can we simplify? No. The only common factor between 7 and 9 is 1, so this is in simplest form, and we are done. 7 9.
So 7 ninths is the answer for this problem. Now, one thing that I really liked about his strategy is that he actually listed the multiples of each of the numbers in the other fraction. To see, in each fraction, I'm sorry, to see which one will be the common denominator that they needed to have in order to make this work. Okay? Does anybody have any questions so far? Are you okay? Is it, the pacing all right? Am I going too fast? You good? Okay. Thank you. So let's erase this. I think I could use some of his videos. He explains really good.
Yes.
Okay. So now let's me go to my book. And I'm going to do another example, okay? Okay, now what if, both of the numbers do not, like on the other one, how we had a denominator be a 10 and then a 5, we just multiply one side. What if we only multiply one side but the other one stays the same? Can we multiply both sides by maybe the same number or a different number? What do you guys think? By different numbers? Can you what?
Yeah, different numbers.
Okay, yeah. Or we can even do the same depending on the denominator. Although I don't think we can do the same now that I think about it, right? Because then it will give us just a double or triple number. Okay, so where is the, okay. Now I'm going to draw. I'm not a good drawer, but I will try my best. Okay? So I'm going to represent this fraction as red. So I'm going to draw from here to, where's the foot, to here, okay? So I'm gonna draw this right here. And I'm gonna cut this into how many parts?
3.
Into thirds or 3 parts. Good, good, good. Thank you very much. So here's one part. Here's the other part. Kind of looks like a flag, right?
Yeah.
Okay, so that is, my whole will be the whole rectangle. And then the fractions would be here. The denominator is this, okay? Now, how many do I have to color, or how many of that fraction are we selecting?
1.
Yes, thank you. Thank you, 1. So I'm just gonna go ahead and color a 1. Now for the next fraction, I am going to use a blue. Okay, and okay. I'll do my best again. Not a good drawer. Now this one I will cut into how many?
Four.
Fours. Okay. 1, 2, 3, and 4. And how much of that are we using? Yes?
One.
1 as well. Thank you. Now the next step, as the video showed us, was to do what? If we already have our fractions and we know they have different denominators, what is the next thing to do?
Add.
Add, but they don't have the same denominator. So what do you think we need to do in order for us to add?
Find the lowest common multiple.
Find the lowest common multiple, okay. And how do we do that? We list them in order, right? So I'm gonna start with the multiples of 3. So multiples of 3. Can somebody help me count? Yes.
3,
3,
6,
6,
9,
9,
12,
12, one more?
15.
15, thank you. Can somebody else help me do the number 4? Yes?
8.
Wait, okay, so we start with 4, then 8, then
12.
16.
16, one more.
20.
20, okay. Do you see any of them that we can use, that match? Yes?
Me?
Yes.
12.
12, do we have a 12 here? Yes. And do we have a 12 here? Okay, so that means that I can break this also into 12 parts. Okay, I'm gonna try to do that. And the bottom one as well. Okay. And then that means that we can rewrite this as, wait, 1 and 2. Wait, I'm sorry. That's a 4. Okay. So I'm gonna rewrite the next one as green, okay? So we're gonna multiply this. How many do we need to multiply this by to get a 12?
4.
4. And then what we do to the bottom, we do to the top, right? So also multiply this times 4. Okay, so 1 times 4 is?
4.
4. And then 4 times 3 is?
12.
12. What about this one? By how many do we have to multiply this number to get a 12? Yes.
Times 3.
Times 3. What we do to the bottom, we do to the top. So then 1 times 3 is 3. And then 4 times 3 is 12. So now that we have this, we can proceed to solve this problem, right? So just to give you an idea of how much this is, this will be 4 here. 1, 2, 3, 4. It's the same. And the next one will be 3. 1, 2, 3. And it's the same here, right? So I'm just gonna represent our total, once we solve it, with a green color. So who can come to the board and add this up? You wanna do it? You wanna do it? Because I was close to him. 7 12s, good job. So that means that if I take the 4 12s from this one and the 3 12s from this one, I'm gonna end up with this result. Okay, so I'm just gonna represent that real quick with my green. This way. I'm gonna divide that into 12 parts. So that is 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I'm gonna color the 7 ones. 7 12s, I'm sorry. 1, 2, 3, 4, 5, 6, and 7. So this represents our 7 12s. Now, can we simplify that? Do you think we can simplify the 7? Or does it stay the same? Yeah, because they don't have another factor that they can both be divided to, right? Because the factors of 7 are 1 and 7, and the other ones are like 1 and 12, 2 and 6, 3 and 4, right? So we cannot go on with that. Any questions?
No.
You guys okay? Okay, so now, here's what I need you guys to do. I need you to go to your book and open it to page 638. May I erase this from the board? Yeah? Okay, who can tell me the first thing I need to do? Yes, Doug.
What?
Oh, sorry. 638. Yes.
We need to multiply the denominator by 2.
By how much?
2.
How do we know it's a 2?
Because 4 times 8 equals 8.
Okay.
So,
Does anybody have a question on how or why do we multiply this times 2? No? Over here? Yes. Okay. So, because, yes, you are correct. We multiply it times 2, but I'm just going to explain why, okay? So the first thing that you have to do, and look at the steps right here, is to list the multiples of each of the denominators so that we can get one that they both have in common, right? So I'm going to list them, the 4. So 4, 8, 12, 16, and what's the other one? 20. Okay. Then the multiples of 8, 16, 24, what's the other one? 32, and 40. Okay. Do we have a common number between these two? Which one?
8.
So 8 stays the same, right? Because it just multiplies by 1. So it stays the same. But the number 4 we have to do, oh, my bad. 1, 2. So this is like the place where they belong, right? So that's where you have to multiply it times 2. And Abraham, what we do to the bottom, we do to the top. Good job. You. There you go. I think I got it.
Yeah.
I think I got it.
Yeah.
So yes, what you do to the bottom, you do to the top. So can you tell me what is 3 times 2?
6.
What about 4 times 2?
8.
8. Now do we have both of our denominators the same? Yeah? Can you solve this on the board?
Like that?
Yeah. Ah, man, nobody has dropped it. Good. So now we have 7/8. Can we simplify this? Thank you. Salud. Let's see. So no, it stays the same again because the multiples of 7 are only 1 and 7. So it's already in simplest form, so it stays like that. Now, how confident do you feel to solve 4 out of 5? Okay, let's give it a try. Go ahead and go to page 639, which is really just next page, and you're going to work. You want me to leave this example here?
No.
Okay. No? Yes, no? I heard more yeses than no's, so I'm just going to leave it up there. Okay? Now, here's what I need you to do. Who can tell me what the odd numbers are? Okay.
1, 3, 5, 7, 9, 11, 13, 15.
Okay, that's good. What about the even numbers?
2, 4, 6, 8, 10, 12, 14,
Okay.
15.
Okay, we got the idea.
13.
Thank you, guys. You are going to work on the odd problems on this page. Okay? The odd numbers on page 639. So you're going to work on problems 3, 5, 7, 9, and 11. That should give you 5 problems, and you need to solve at least 4 correctly, successfully. Okay? Yes?
Do we also do number 13 on the bar?
Only if you are done, and if I tell you, green light, you're good to go. Okay. What was your question? Oh, any other questions before we get started?
No.
All right, let's start. I will be walking around, and if you have any questions or get stuck, please let me know. Okay, you have a question? It doesn't matter where they go. I just did the smallest one at the top and then the biggest one at the bottom and see which ones they have in common. Okay? I will come back and check your problem. Do you remember which ones you have to do? Which ones? No, you don't have to do all those. You have to do the odds. Okay? So 3, 5, 7, 9, and 11. Those are the ones you need to be working on. When you're those are evens. Yeah, those are even numbers. Let me see. Yes. Yes. I'm sorry? You had to rewrite your fractions. For example, how do we by which number do we multiply 3 in order to become this number? By 5, yes. And what you do to the bottom, you do to the top. So now you kind of have to rewrite your fraction. Okay, so what's your fraction going to be?
515.
Correct. What about this? By which number do we have to multiply it so that we can get a 15? By 3, and what you do to the bottom, you do to the top. Okay, so what's your answer going to look like? 3 15s, right? And then when you add that, what do you get?
815.
Correct. Now, can you simplify it? I don't think you can do, because the 15 you can divide it by 3, but the 8 you can't divide by 3, so you cannot simplify it. So that means that, you know, they stay on that answer. So that's what you write. And I really like how you're showing me your work, so that way I know how you are processing this information and how you're reasoning and how you're thinking. So great work. So the number what? Did you already finish with the other ones?
Yeah.
All right. Okay, that's good. What's your answer on this one? Yeah, all right. So that's like 3, so that's 3 over 3. No, wait, 8 over 12, right? 8 over 12. And that, you divided it by 4. Okay, yeah, perfect. You're also done? Okay. Yes, you can start trying out the next one. Okay? Yeah, if you're done, you can move on with the algebra section. All of them, the 3. Yes. Good. If you're done, are you done too?
Yeah.
Okay. Everybody, if you're done, continue to work on the algebra. I'm just gonna check real quick. That's okay. What do you mean, Adam? This one?
Not this. Algebra.
Well, this one you have to find the value of each. So, this, when you solve it, X is going to be your answer, really. But on this one, it's already giving you how much is going to be from the numerators, but the Y is the one that you have to find. So it's kind of like solving it and just write down one number, one. Depending on which letter it's asking you for, that's what you're going to write in your answer. So on this one, for example, we can see that it's the whole fraction, right? This one is just the one. And this one? You're done? Continue working on the other ones. Yes. So on after you get the multiples, and after you find the common multiple, what is the next step? Look at number 1 over there, or you can look at the board. It tells you to kind of like rewrite your fraction, no? So what number do you have to multiply the 3 by in order for you to get a 15?
By 5.
By 5, yeah. And what you do to the bottom, you do to the top. So now, can I borrow your pencil? So now you have to multiply this one by 5 and this one by 5, okay? So what is 1 times 5?
Okay, so really how to do it is just
5. What about 5 times 3? 15. We put the addition sign, and oh, we still have to figure this one out. We still have to change it, right? So what number do we have to multiply this one by to get a 15? Thank you, guys. Because some of your classmates are still working, okay? Okay, thank you. I'm helping this table. After I'm done, I'll go with you, okay? So what did we multiply the 5 to get a 15?
3.
By 3, good. So 5 times 3 is 15. So that means that what times 3 is? 3. So now you add it just like if it was, because now those numbers are easier to work with. Okay? Good.